In this problem, we're gonna reflect the point M that has coordinates x, y about the line x equals a. We will obtain this point M prime that has coordinates x prime, y prime. Okay, in this case, we know, because this is a reflection, that this point is in the middle, the point I, and at the same time, I belongs to this line, x equals a. Okay, so to find the coordinates of this point M prime, okay, so we need to express M prime in this x, o, y coordinate system, rectangular system. Okay, remember that we always refer by vectors to the origin. Okay, here this is OM, this is OI, and this is OM prime. Okay, but we know here we can use the fact that the vector IM is minus IM prime. Okay, because these two vectors are the same, but they point to two opposite directions. So to make them look the same and point to the same direction, we add the minus. Adding that minus, we're gonna obtain IM prime is minus IM. So now we can use vectors addition. Okay, here we're gonna add the vector O. So we have AO plus OM prime is equal to minus AO minus OM. Okay, our interest is in this one. So OM prime is gonna be minus 2IO minus OM. But since we are interested in the origin, we're gonna do 2OI minus OM. We know the coordinates. Okay, now we know the coordinates of I with respect to the origin. Okay, so I has coordinates AY. Okay, and M has coordinates XY. M prime has coordinates x prime, y prime. We don't know this. This is the one we are looking for. Therefore, if we can write this one, we can write in component form. So we have, this is OM prime. We have x prime, y prime. It's gonna be 2OI, that means 2A, 2Y minus OM is just XY. Okay, therefore we have 2A minus X, and 2Y minus Y is just Y. Therefore we have X prime and Y prime in terms of X and Y. Okay, this gives us that X prime is 2A minus X and Y prime is just Y. Okay, so this is the expression, this is the analytic expression of this reflection with respect to this line. Okay, the line here, Y or X equals A. I'm used to Y, that's why I say Y, but it's X equals A. Okay, so the key is that if we know the coordinates of X and Y, and we know the line, we can easily find X prime, Y prime. Okay, so we can see this one as a reflection. So you bring your object back here, okay, and you reflect it, and you translate it 2 units. Okay, 2 units by your 2 units by A. That means 2A. Okay, so because here we have X prime, Y prime is minus XY plus 2A0. Okay, think of it this way in terms of vector addition. Okay, let me write it down here. So X prime, Y prime is gonna be minus X, Y plus 2A0. This is the vector that we translate with respect to the which is parallel to the x-axis. Okay, 2A. So you translate 2A, 0. Okay, you translate just the x. The y will be the same, but you reflect the x. Okay, so what we do is So if we find the image of M, we reflect it about the original y-axis here. So what do we get? We get minus x minus xy, and after that we translate that by 2 units, by this vector here. Okay, that's 2a0. Okay, and that's how we obtain our expression for the, this is the one that we need, the expression for the reflection about this line. Okay, thank you very much.